everyone, and welcome. It is May the 8th. Wow, 2024. And we are here with the Knowledge Bolide Hangout, the Knowledge Bolide crew on the Knowledge Bolide Hangout for the Meteoritical Bulletin Database. My mouth barely got that out. Sue's been working super hard on this presentation, and I'll just give you a little 10-second spiel of what the Meteoritical Bulletin Database is. The MetBull, as we call it, is the Bible of meteorites. It is a database repository for all officially recognized by science meteorites. It gives their scientific information, their geochemistry, their history, their ownership, and different information as far as that goes. So what we're going to be doing today is checking in with Sue for a MetBull update 2024, March and April. Hey, babes.
Hi. Thanks for that introduction. I just wanted to actually say I pulled up the MetBull just now, and that repository is now filled with 74,345 meteorites as of today. So that's pretty amazing. Before we get started, I am just really excited about a new purchase I made, and I wanted to share that with everybody. If you can see my necklace, I got this from Prairie Girl Rocks, Allison. She makes really badass jewelry, so go check her out. Check out her YouTube channel. Look at that. How cool is that?
Yeah. I think it's really cool.
Just had to share. All right, guys, for today's MetBull update, we will be reviewing meteorites that were officially approved, classified, and published in the MetBull during the months of March and April of 2024. And that brings us to 863 meteorites. First, we're going to cover what was classified in Antarctica. All right, so they were really busy down there for the last 2 months. As you can see, there were 144 ANSMET reclassifications, reclasses. And then we had 126 new from ANSMET and 147 new from KoreaMet, who I haven't really seen before, but they actually have a good deal of classifications. So on the next slide, we will see that out of the reclassifications that they had in Antarctica, there were 10 new classifications that came to be, and they are on the screen in no particular order. And on the next screen, I just grabbed a few of them. This is not all of them, but a few examples of some of the classifications, the path of reclasses that they've been on. And as you can see, like that last one is CV3 to CV3 anomalous, back to CV3, back to CV3 anomalous, and then finally on the CVOX A3.7. And there's a few other ones. You can see one went from a room of Rudy through a few Carbonaceous and landed on the CVOX A3.5. So pretty interesting stuff. Like I said, there were over almost 150 of these. So those are just a few examples.
And Sue, if I remember correctly, we have a special guest and Daniel Sheikh joining us later to talk about classification.
Yes, during our little I'm not going to touch too much more on reclassifications here, but we do have a few featured ones that we're going to cover, and Daniel Sheikh is going to tell us a little bit about some of this whole CV to the new CV classifications.
Awesome, because when this happened, you and I were looking at each other dumbstruck, like, what in the world is going on? So,
and I know with one of them, and we'll talk more about that later, but with one of them, from Jason Whitcomb, he advised me that the reclassification was done without any new material going in. It was just done from the initial analysis. So pretty interesting stuff. So Daniel will tell us more about that a little later. So for now, I wanted to talk a little bit more about KoreaMet. So yeah, that's the Korea Polar Institute, Research Institute. So yeah, there's a little video here. So it's a government-funded COPRI program, and it's for the recovery, classification, storage, and distribution of Antarctic meteorites collected by the Korean Expedition Party from South Korea. So they started operating in the summer season of 2006 to 2007. And then over the next 3 years, they collected 29 meteorites at the blue ice fields of Thiel Mountain. And that's in the West Antarctica. So since the 2010-2011 season, they've been searching more in the Victoria Land area of Antarctica. and especially in the blue ice fields of Elephant Moraine, which is where their new classifications are based. So I went to their website, and it includes a repository of many of the meteorites they've found. They also have like a cutting and polishing schedule set up. And through their search of meteorites since the 2006 season, they have found over 1,150 meteorites so far, including a lunar and numerous primitive chondrites.
Very cool. I would love to go spend a weekend with them. Look at that.
Look how easy it is to see a meteorite out in the snow. Like, how cool is that? All right, so moving on, I just wanted to show you where they found their new 147 new classifications, and that's in Elephant Moraine. And then on the next slide, you can, I just kind of zoomed in so you can see it's in the Grand Central Station of meteorite ice fields. They're right there, smack dab in the middle. So anyways, that's our report for Antarctica. And moving on to the rest of the meteorites, that leaves us with 393 meteorites to cover. So the rest of the data, like what I'm talking about, classifications and locations, we're going to leave those Antarctic meteorites out. We're just going to be focusing on these 393 meteorites that are available to the rest of us who are scientists in Antarctica. So, all right, we're going to cover confirmed falls first. There were 2 confirmed falls during that time. And so the first one was Boorama. And this one fell in December 6th of 2023. And it fell in Awdal, Somalia. It was classified by Marcus Patzek. So I'm going to read a little bit from the entry in the MetBull, because I read this at Topher and we thought, oh, this is so cool. So at like 3 a.m, the Muhammad family heard shattering noises and loud cracks of thunder, accompanied by a bright fireball illuminating the whole area. They were fascinated and frightened and decided not to go outside. They stayed in place. They heard the loud hissing sound. They heard something hit the ground. They waited till after sunrise to go outside. And they found it relatively quick because it's really light colored sand everywhere. And then there's this black thing on the ground. So one relative went out to go get it. He brought it in. It weighed 431 grams. And he called his nephew in Germany, who he knows about like geological stuff, and his nephew said, I think that could be a meteorite. So they contacted someone named Stephen Decker from Meteorite Museum in Oberwessel in the Middle Rhine in Germany, and they described the incident to him. And so Stephen Decker ended up purchasing that meteorite a few months later, and then he gave the family instructions on how to go out and search for more. So over that time from like January, February to March, like they ended up finding a few more stones and determined that the stream field is about 14 kilometers long. So I thought that was really cool. They had no idea what it could possibly be, and who would have thought a meteorite outside? So I hope that they were paid well for that. So our next witness fall is actually one that you guys have probably heard of, Mvskoke Merkv. And I'm not going to say too much more about it because you guys are going to hear enough from me. So I'm going to turn this over to our Conversations with Hunters, Roberto Vargas.
Roberto, welcome, my friend. Good to have you on board.
Thank you. Good to be here. So for those of you who don't know, my name's Roberto. I'm a meteorite hunter. I live in Connecticut. And I was one of the first responders, if you will, to the Mvskoke Merkv fall, which happened on January 20th at 3:30 in the morning. So it happened on that morning. I started coordinating with other hunters, basically Steve Arnold and I flew out there. We were out there on the 21st. We searched the 21st. We didn't find anything. And then at 11:30 in the morning on the 22nd, I found a 309-gram fragment. So this is me in the field.
This is it right here. I'm teasing. There it is. We're gonna go back to it. There it is.
Yeah. So that's me in the field where we found this 309-gram stone. And at that point, we didn't know that any meteorites had been found from this fall. So that was, to me, the first stone found. Wow. I later found out that a small 70-gram stone had been found a couple hours earlier, but nobody had that hadn't been known at that point. So It was really exciting. So on the 21st, we started hunting. We didn't find anything, Steve and I. Then Steve went back to Arkansas because Arkansas and Muscogee were relatively close. And I started hunting with Rob Wessel and Mike Bandley, West Coast hunters. And about 3/4 of the way through this field, I come across this. And there are, cow patties throughout the whole thing. I really wasn't sure this was a meteorite at first. My heart dropped, obviously. When I bent over, picked it up, and it was solid. I was sure I was going to pick up cow poop when I bent over, but I was willing to take the risk, and it paid off. So that is the 309-gram stone. So that I found that 2 days after it fell, and then on February 19th, Brad Ward, a local from Muscogee, posted that he thought he found a meteorite, and he posted this picture on a Muscogee Facebook group. And at that point, I reached out to him. And when I reached out to him, I was actually in France because a meteorite had fallen, had been tracked from space and fallen out there. And we found the biggest, Steve Arnold and I found the biggest piece out there. Brad
a nice gentle flex, by the way.
Yeah. Always gentle. So I called Brad and I was like, "Hey man, I'd like to buy it from you if you'd be willing to sell it." And Brad and his wife Jolene were the nicest people on earth, man. They invited me over, we talked. They sold me the meteorite. They cut off the section of paneling. They even agreed to do an interview for the Knowledge Bolide, which was really cool. So I was able to
Thank you for bringing that up and bringing that opportunity to me. Because when am I, a YouTuber, going to get the opportunity to do a one-on-one, basically, interview with a hammer family in Oklahoma? Without you, Roberto, out there in the field doing the hunting and bringing connections like that, that's beautiful content that we would never have had. So if it interests you, search the channel for it. But yeah, thank you again for involving me in that.
Absolutely. Really interesting fact, too. This is Brad here in this picture cutting off the ceiling, but his wife, Jolene, is actually a relative of one of the people who recovered the Lost City meteorite like 50 years earlier. So it was really cool to have that like multi-generational story. This is the 390-gram hammerstone. This got bought up real quick. It's in a personal collection now. Very, very small, very, very little of this material is even out there. I think I made 5 or 6 little micro pieces available. But yeah, that was a really, really awesome experience. 260 grams of this material. So the total known weight ended up being 1,421 grams. There were 6 stones. I found the one, I bought this one, and then there were 4 others. Pat Branch, I believe, found 2. One not far from the 309 gram that I found, but 260 grams of this, an individual went to the Oklahoma State University, and 10 grams was actually gifted to the Mvskoke Indian tribe that actually is from that area. So Elizabeth over at Errachidia Meteorites was really instrumental in making sure that the Muscogee people got a piece and got a say in the naming of this meteorite. Yeah. So for those of you who don't know, Mvskoke Merkv is spelled MV, and that's just because of that Muscogee Cree, their language. And what Mvskoke Merkv means is Muscogee's blessing. So it's a really cool story. It's one of those meteorites with a Native American name, which is really, really rare. I think one other one, your birthday meteorite, Deshibiko.
Yep.
So
I was thinking the same thing. And that's one of the delays that brought bringing this to the MetBull update where we got to today. Is even though you found this 2 days, not this one, but you found the 309 gram 2 days after it fell. Only now is it getting added to the MetBull. It probably could have been added if those involved wanted or were satisfied with Muscogee or Muscogee Creek.
And if you remember, Topher, we actually brought the first sample to Arizona State University.
Yeah.
February 6th, I think, with the Meteorite Mansion when we did the ASU Vault Tour. So
Yeah,
it was
that
really
was not.
cool to.
Yeah, that was not a weak flex. That was a strong flex, my man. Right.
Yes.
And on a very, very side note, on my day job, I do sell computer technology for a living, and I have a client. I had a client in the past called Muscogee Creek Nation Health Clinic. So I used to sell computers to Muscogee Creek Tribal Health Entity, and never heard of them besides that. And then all of a sudden, a meteorite falls in their backyard, and now it's approved as a MetBull with my friend Roberto involved. Thanks a lot, man. Really appreciate you checking in on that story and closing loop all the way from finding it to submission to classification.
Thank you for having me.
I always like to update our viewers with some of the stuff going on in the chat. And I will say when Roberto was talking, John chimed in saying, boots on the ground is always golden. And yes, we totally agree. And we appreciate Roberto always coming live streaming with us it's been from a few different countries, I think.
Yeah. Yeah.
And then earlier when we were watching the video of the Korean expedition, Ken said, that's so wild with them sitting in the hole that they dug to drink hot drinks. And I agree. That was one of my favorite parts of the video too. Yeah. And lastly, Oz said greetings to all fellow Earth dwellers when he joined the room.
Welcome, Oz.
That was awesome. Anyways, okay, moving on. We are on reclassifications. So as I said before, there were 197 altogether. However, most of those were in Antarctica. So that leaves us with 51 standard reclassifications. And that's of the other countries besides Antarctica. So the first reclassification, I'm featuring two of them. We're not going to go over all 51, of course. So the first one was one that Jason Whitcomb shared with me. And we do have a lot of that. Jason always shares a lot with me for every MetBull update. I am going to talk him into coming on someday. He's a little camera shy, but he always gives me lots of information and lots of pictures, which I really appreciate. So thank you, Jason. So this one was one of the CV3 that was reclassified as a CVOX3. And Topher just has a few pictures to share of it. But for the next reclassification, and this one was reclassified, this was the one that was reclassified by Christopher Hurd up in University of Alberta, and he just used whatever information he already had from the original classification. So Jason was like, thanks, Chris. And so I am going to turn this over to Conversations with Classifiers featuring Daniel Sheikh to talk about our next featured reclassification and just the reclassifications in general. So over to you, Daniel. Thanks for being here.
Sounds great. Thanks everyone for having me. For everyone new, I'm Daniel. Nice to meet you. I'm a third-year PhD student at Portland State University, majoring in geology, but although I'm very focused on lunar meteorite geochemistry, and in my spare time, I like to classify meteorites. That's sort of a fun thing that I like to do. And today, well, one of the topics I'll be focusing on is sort of why reclassification occurs, and I guess maybe a bit into the progress of how it sort of went. So Sue showed a really good example of one of those CV3s, and I think on the next slide there was something that that one right there. So basically, this sample NWA 13295, this was a sample that I initially classified for Stephen Amara, and initially this was classified as a CV3, but you'll notice that now it gets changed to CVOXA3, and you're probably wondering where those extra letters came from. And that's kind of one of the interesting things, is that as scientific research evolves, so as more publications go out into scientific journals, more scientists start changing existing nomenclature systems that we have, and that includes the classification system of meteorites. And so there was this recent paper that came out about 4 years ago. It was from a specific author, and what they were addressing was that within the CV chondrites, there was sort of two types of subgroups. There were what they call the oxidized subgroups and what they call the reduced subgroups. And without going into too much detail, the main difference was that they were trying to imply that these actually came from separate parent asteroids. So that not all CV3 chondrites came from just one large parent asteroid, but rather there were a few of them, at least. And so in order to distinguish CV chondrites from one of the asteroids, they now implemented the system where you can put the oxidized or reduced sort of symbols into the classification. So if you're trying to do research on these meteorites and you just want to look at oxidized CV chondrites, well, now you know which ones are oxidized and which ones are reduced. The A is because of the fact that within the oxidized CV chondrites, there are two types, and this just depends on what kind of minerals that you see in these assemblages. But there's the A, and then there's the B type oxidized CV chondrites. So this one in particular, I classified initially was CV3, but I wrote a lengthy description of what minerals were there. I think I also put magnetic susceptibility in there, and I put some other things. And therefore, nomenclature committee later, when they were doing reclassifications, they saw that I had this extra data in the submission. So they contacted me actually, I think it was a few weeks ago, and they told me that some of my classifications were going to get updated, like this one, for example. And they asked me if I was okay with it, and obviously I'm perfectly okay with any sort of changes. And so they were able to update it to this specific classification. So this is just an example of how the nomenclature system evolves as science is growing and more research is done.
Well, Daniel, I have a question for you. In going forward, will the falling into the oxidized or reduced A or B, will that be done automatically for all CVs moving forward, do you believe?
It depends. One of the difficulties of doing that is if there was initial classification work done, but there wasn't, for example, they never got magnetic susceptibility, they never looked at specific minerals in there, or they never reported it, it's very hard to make that update classification because you need that updated information to do so. So I think only for the ones that have a lot of descriptive information in there that gives a nomenclature committee enough information to say that they want to change it, I think for those ones specifically. That's probably why all of them haven't been updated.
Yeah. Not so much as far as changing new submissions moving forward. Do you think they, as a classifier, are you going to request all the material that is needed by default to get that further clarification, or by default, are you just going by what you normally ask for?
Usually it's by what I normally ask for. So when I do the initial classification work, as part of the classification process, we need to have material that is put on deposit in a type specimen repository to be used for any kind of future research. And normally we also have thin sections that we use to look at the sample, do the classification, and those are also kept in the repository. So if for any sort of reason I need to go back and relook at something, I would look at the same thin section that I looked at when I did the initial classification work, just to double check something. So I wouldn't necessarily ask for more material, but there are cases, for example, where if the type specimen mass is very low and I might need a sample from a different part of that meteorite, because as we know, meteorites most of them are breccias, so they're mixes of many different kinds of rocks. Sometimes you get a slice of a meteorite and you get a second slice and they're completely different. Sometimes I may request a second slice of a meteorite. If my classification doesn't exactly match something, or if I'm trying to look for a specific thing. So if I'm doing a reclassification of something, this isn't really something I would actively do unless I'm not 100% sure on what that initial classification is. So one good example would be something that would be classified as, let's say, you might have seen in the Meteoritical Bulletin as an L/LL3, something like that. And generally, if I wanted to do a reclassification and find out, well, is it L or LL, I would probably want to get a small piece of it and send off for oxygen isotopes or something like that to really narrow it down. But if there's no need to do any sort of further reclassifications, then I would just say I'm good with the current submission.
Fantastic.
We have a question from Roberto. He wants to know if some of the more famous ones like Allende, do you expect something like that to be reclassified?
So it's actually interesting that you mentioned that, Roberto. So if I'm correct, the oxidized subgroup A was initially for Allende. So that's where the A comes in. And then the B is from Bali, if I'm correct. So based on, of course, lots of research, that Allende is one of the most studied carbonaceous chondrites in all of meteoritics. In fact, there's been so much work done on looking at Allende that they've been able to find so many things of that. And that's kind of one of the reasons why we have these different oxidized subgroups, is all the work that's been done looking at Allende, Bali, and a whole bunch of other carbonaceous CV chondrites.
Awesome. Thank you very much. Yeah, we could go down a rabbit hole with you, buddy. But Daniel, thank you so much for your constantly coming on here, supporting the crew. You're a strong pillar of our scientific knowledge. So thank you very much for sharing it with us every time.
No problem. Thanks for having me.
Thank you. Sue, back to you.
We're going to hear a little bit more from Daniel later. And I feel badly. I feel like I didn't give him a good enough introduction, but Daniel, everybody knows who you are. You're very famous already. So
classifier to the stars.
Yes, thank you for sharing a little bit of your background there. I appreciate it. All right, so now we're going to move on to locations. All right, so there were 3 meteorites that I think 2 finds and 1 fall in the United States. The first one was Gypsum Spring, and that's an H6 chondrite that was found by Terry Scott, familiar name. And that was actually classified by none other than Daniel Sheikh, 227 gram total known weight. The next one is Wellman, and that one was found actually way back in 1999 by Mr. Darrell Ellis while plowing a cotton field. We hear this a lot, right? Farmers on their fields. It was about half a mile away from the highway and about a quarter mile east of his water tower. So he found this, he stored the unusually dense stone out in his garage until someone purchased it 5 years later. And then portions of the main mass were subsequently sold to other collectors. So that one, the very last one for the United States is one that we just talked about, and that was Mvskoke Merkv. So moving on to other locations, there was a meteorite found in Lombardia, Italy. It's called Monte Castone. That was an H5 chondrite found by a Federico Pogliani, and he was not looking for meteorites. He was looking for deer antlers and just happened to come across a meteorite. So very lucky find. So don't be jealous.
I'm jealous.
Okay, next one. I just condensed all of our Chile information. Obviously, they were all found in none other than Antofagasta, Chile, and I have all the dense collection areas listed, no particular order. And then next to each name is a number, and that is the highest number found so far of each one. So, like, if you have one that's like 200 and something, there have been 200 and whatever, 34 meteorites found in that dense collection area. Some of them have much lower numbers. So that's 162. So we'll continue seeing Chile's numbers like just climb and climb. And I think they're going to be like the highest country pretty soon. All right. So I have 2 maps of China. There was one found in Xizang. And then on the next slide, where we usually see meteorites found in China, in Shun-Chung, there were 4 of them. On our next slide, I believe there were 6 found in Iran. And the next slide shows Northwest Africa, 138 there. And the lastly is the countries, where it's not, it might be an NWA, but they actually have the country instead of just Northwest Africa. So I blew through that geography portion kind of quickly so we could focus more on classifications. So we're going to move into classifications now.
Let me interject for 1 second.
Yeah.
I'm sorry for this, but I did want to just expound a little bit more, because there's 138 in Northwest Africa. And then on the next map, there's only, 75 here. The other batch of them are listed as NWA as the location, whereas these are from the NWA location, but in the MetBull are recognized from a particular country, correct?
Correct.
All right, thank you. I want to make sure I got that.
All right, we are going to look at classifications now. And the first classifications we always cover are achondrites. And so Topher has you guys on mute, but we're going to allow you guys to come off mute for the next minute or so, because I have 3 pictures of a classification, and I want to see if anybody can guess what this classification is. Raise your hand if you have a guess.
I'm gonna go ahead and just tell people what I see. A beautiful meteorite.
I was really shocked when I saw what classification this was. And then I asked Topher, and he guessed it almost on the first guess. And I'm like, you're a jerk. Shut up.
Oh, it's beautiful, though. It's of the metal-rich variety.
All right, guys, don't be shy. Come on, take a guess.
All right.
Beautiful.
Mike Lake, the newest guy in the building. Awesome.
Yeah,
Always wanting new feedback. Go for it, big guy. What do you see?
Okay, my guess would be Palisade.
Okay.
And that's what Greg guessed in the comments as well.
Any
other guesses?
What makes you say that, Mike?
You have the clumps of the iron, and then you have the crystals along with it.
Okay. Great. Thank you so much for jumping into the cold end, the deep
Yeah.
end, man.
Absolutely.
Anyone else?
Yeah, I want to take a different guess at it.
Go for it.
Is it an ungrouped palisite?
It is not an ungrouped, and it's not even a palisite.
Okay, well,
So
I
you
was
are-
wrong
so
too.
both of you are
Congratulations to me.
incorrect, but solid guesses.
Yeah.
Dave Pinsky, can I get your opinion?
Would it be a silicated iron?
I would say no. Well, no, the answer is no. But with a silicated iron, you'd see a lot more iron and a lot less silicates. This is an iron silicate,
I'm
Mhm.
grasping at straws.
which doesn't exist.
I guessed olivine diagonite, but I would say there's way too much metal in here.
Way too much metal in there for a diagonite.
Yeah, good guess.
All right. What we're looking at here is a transitional meteorite of some sort. It's going from one type to another type, basically. Does anyone else, maybe our veterans, have a opinion on this one?
Pat's being kind of
I think I know what it is.
Roberto, what do you got, buddy?
Is it a Winonaite?
A Winonaite? Pat, what do you think?
he is pretty damn close.
Well, it's one of those pesky achondrites. I was going to guess high metal Winonaite as well.
We have two guesses for high metal Winonaite. Anyone else?
Bruce guessed mesosiderite, which was my very first guess.
Yeah.
And I think it really looks like a mesosiderite, but I think I'm going to reveal the answer now. It is a kind of Winonaite. It's a brand new classification. This is an anomalous Winonaite.
What?
Yeah,
Yep.
it's a one of one. I did not think it looked like a Winonaite at all. So good guess to the people that kind of toward that.
Cool.
Yeah, that's cool.
Yeah.
Go ahead.
It looks a lot like Craig Zlimen's recent ungrouped achondrite that also looks a little bit like a palisite.
Oh, I should also mention, I didn't include it in the presentation, but I looked at the isotope charts for this. And a lot of the charts, if you look down below the chart in the MetBull, it will tell you what the closest neighbors are to it. And I think the second closest neighbor is one that a lot of us are familiar with, and that's Errachidia 004, which is Topher's classification, which had the low metal and the high metal pieces. So I thought that was kind of cool. So, all right, we're going to
cool.
Yeah. So I think the next slide after the picture is our Achondrite classification. So there you see it, Winonaite anomalous. It was one of one. Obviously, acapulcolites are rare, but they're not like, I think they're probably close to 100 now. So now that we've seen the Achondrites, I'm going to turn it back to Daniel, who is going to talk to us about an ungrouped Achondrite that he classified during the time period that we're covering.
Daniel, I wonder if you can just work this into your pre-canned answer on this. When you're testing a palisite to get the anomalous, you need to test the metal, and that's the metal composition is what gives it that anomalous status. Is that the same thing in a Winonaite?
I've spoken with the nomenclature committee about the high and low metal, and when I did Errachidia 004, they told me that wasn't a distinct reason to give the anomalous classification. I'm wondering if there might be something different in the specific composition of the silicates or the metal. I'd have to check that to see why that one was specifically anomalous. But if it is something that was related to something that Errachidia 004 had, then I may need to go back to that one and get that one changed to anomalous also.
That wasn't why I was asking. I was just looking to learn. But
it was good that you brought that up because I saw the sample and I was just curious what made that specific one an anomalous. But
yeah,
I'll go ahead and look at that one.
Thanks, man.
Yeah, no problem. So this one, this is a Chondrite ungrouped. So this is NWA 15487, and a bit of a story on this one. This one took about 2 years, roughly, from start, which is when I received the sample from Youssef Bennani. He sent me a piece of this material, and it was interesting when I saw it. I was wondering whether it could be related to a Ureilite or whether it was some terrestrial rock. So I made a thin section of it, and at the time, our SEM on campus was sort of down for repairs. And so I was looking for someone else to work with. So I sent the thin section to Anthony Love at Appalachian State University. He also classifies meteorites, and we worked together on a LL 3.5 in the past couple of years.
Thanks.
So he was doing some of the initial work using the SEM, and he said that this was compositionally similar to some of the stuff you see in Ureilites. And that was kind of my first impression when I was seeing this in thin section. And then I sent off a piece to get oxygen isotopes by Dr. Richard Greenwood at Open University in the UK. We were mainly just wondering to make sure that this was a Ureilite, but there were some things that I was seeing in there that weren't really consistent with Ureilites. And so when I initially submitted this sample to the nomenclature committee, it was actually rejected. My submission was Ureilite, and they rejected it on the basis that the chemistry of the olivine was not matching that of olivines from Ureilites. And so I rechecked that just to make sure, and they were absolutely right. It wasn't matching that. And then I said, well, maybe this could be Ureilite anomalous because we received the results from the oxygen isotopes back from Richard Greenwood. And one of the things about oxygen isotopes is we treat it as, in meteoritics, we treat it as sort of the fingerprint for what sort of parent body it might have come from, because whether a sample is from Earth or from Mars or from the moon or from the HEDs or from LH, LL chondrites, for a lot of different bodies, they tend to have very distinct oxygen isotope signatures. And we can use this to sort of give us a fingerprint along with doing petrography and getting mineral chemistry to really narrow down and say, all right, it's this meteorite group. It can't really be any of the other ones. Or at least we can eliminate what it's not, per se. And so for this one, it was, this chart doesn't do the best job at showing where it plots, but it plots close to Ureilites, but not perfectly on them. It's sort of a little bit higher in this what we call cap delta, or sort of that triangle, delta 17 oxygen. It's a little higher than where Ureilites are, but it was similar. And so I said, well, maybe this is an anomalous Ureilite. So I submitted that to the nomenclature committee. That was also rejected. The idea there was that even if this was something that could be anomalous, there was still something about its chemistry that was different from Ureilites. And so I went back and I did a second SEM run of this sample. So that the instrument came back online on campus. I was able to go back, get more data, and I found some very weird things in this sample. So if you look right here, oh, this is actually a great photo. So if you see those white lines are essentially a mix of weathering veins, as so we call them. So there initially was either metal or sulfide there that was altered to iron hydroxides due to the fact that these samples have been sitting on Earth for a long time. And so you can actually see this large sort of grain, mineral grain, that's defined by those lines. Mm-hmm. And essentially that was the original grain boundary of what this mineral was. And so we thought it was an olivine grain, but the olivine is actually heavily almost altered completely. So that dark gray that you're seeing that's kind of forming these little like wavy bands, that's the olivine that's left over. And what we think happened is that we think that on this asteroid body, wherever this meteorite came from, it underwent a chemical reaction where olivine that originally had formed was reacting with some kind of carbon source. We think graphite. So graphite is, of course, just a carbon material that's present in a lot of these parent bodies, depending on where you're at in the solar system. We think it's from the outer solar system. And so the reaction took place and you formed other minerals as a result. And so the olivine that was left behind had this little wavy and altered texture to it. Now in Ureilites, you see the same process, but it's very minute and you only see it on the edges of the grains. Here, we think this process went to almost completion where all of the olivine was altered to form this new sort of texture that you see in these new mineral things. And so what this means is that this could not have come from the same asteroidal parent body as the Ureilites. This had to have come from a similar parent body that probably formed in the outer solar system, but had underwent this metamorphic, or if you want to call it in sort of an aqueous alteration, sort of some sort of reaction where this process went to completion, unlike in the Ureilite parent body. So therefore, we changed their classification entirely and said, okay, this has to be from some ungrouped parent body that we have not sampled so far. So I was looking in literature. I was trying to find examples of other samples that had this texture, and I couldn't find them. So we settled on ungrouped achondrite. The nomenclature committee agreed, and 2 years later, we finally got it approved. But It's a very weird meteorite, and Anthony and I are probably going to write an abstract on this soon, because it's just interesting to see how compared to Ureilites, a reaction went much further in completion that you took olivine and altered it. So
I know it's really super early, but it's some of the thought processes that you're looking down, like the aqueous alteration, because maybe more water was present, or because more time was present. What do you have any opinion on that at all?
It's a bit tough to say. So the thing is, we know there had to have been some kind. We call these things reducing agents. That just means that you take iron from the olivine and you put it somewhere else, like metal. And we know that in order to facilitate that, there had to be some reducing agent. So our idea was that there had to have been carbon in the form of graphite. And based off of its oxygen isotope characteristics, we know this had to have been probably similar to Ureilite. So we think it came from the outer solar system, where you had, carbonaceous chondrite parent bodies that, if some of them underwent differentiation, right, you formed a crust mantle and core, you could maybe have enough carbon in there to facilitate this reaction. So we think that it's related to those. I mean, we don't have like that much other work that we want to do. So it's kind of preliminary work that we've done so far, but we do think that whatever chemical reaction took place in Ureilites, we think the same reaction took place on this parent body. And maybe there was more carbon present, maybe there was more time. So one thing about Ureilites that's interesting is that a lot of Ureilites, or we think, came from a body that disrupted very early on in its history and broke up into many other bodies. And then those, eventually we sampled those. Perhaps this sample came from a parent body that was intact for a lot longer, and therefore this reaction was able to take place on a much longer time scale.
Gotcha.
That could be true. We have to look more into that, but that's a good idea.
Fascinating, man. I love the fact that you're like a modern day meteorite Sherlock Holmes, man. You find one little thing that doesn't, maybe it's because they kicked it back to you twice, but you find that one thing, you hone in on it, next thing you know, discoveries are made. Thank you very much, man.
No problem. Well, that's one way how learning goes with meteorites and with classification, is that you find one thing that's unusual, and when you have more sets of eyes to look at the sample, and so you have 7 or 8 members of the NomCom plus me and Anthony and plus a few other collaborators, and we all sort of can come up with more ideas. That's kind of how the science evolves, is just the sharing of new ideas, and we all learn from this.
Yeah. When I first got involved in meteorites and I heard something was anomalous, I would think, well, it doesn't fit in. It's an oddball. It's like, but those are what we're looking for. Science, I'm speaking from your point, that's what we're looking for. That's what we're hoping to discover. The classification process is about getting the many into few. So if we have even more precise few categories to put them in, like the oxygen level and the A and B, we're talking about the CV class, that's all taking this to the next level. And you're going to be seeing that on our Hangouts too. So now you know what we're talking about. Sue, back to you.
Okay. All right. So now we're going to talk about HED meteorites, and that is Howardite, Eucrite, and Diagenite. All right. So as you can see, we do have a few rare ones on there. We have a Howardite anomalous, which is one of 2. We have Howardite melt breccia, which is kind of a newer classification that we talked about during the last update. There's only 6 of those now. We have Eucrite monomicte anomalous, which is one of 2. And then we have a Diagenite melt breccia, which is one of 10. So lots of rare meteorites. And I think for the last time, we're going to be going back to Daniel one more time to
I'm
talk
getting
about.
bored of him already.
No, we're not. He's fascinating. So we're going to talk about, I think this is our last segment with Daniel. So we're going to talk about NWA 16533, which is an anomalous Howardite. It's one of 2. So let's turn it back over to Daniel.
So this one is NWA 16533, and it's classified as Howardite anomalous. And this was actually sent to me by Tim Stout, who he is a meteorite collector in Oregon, in Portland, and he was local when he brought over this sample that he thought was a Howardite. I thought it was a Howardite. So the thing about Howardites that make them interesting is that whenever you see them, they're heavily brecciated. So you've got all sorts of different classes in them. You can even see all just from the colors that we've got different kinds of materials in these meteorites. And generally, these are essentially from what we think are the upper surface of Vesta, or 4 Vesta, which is the second largest asteroid we have in our solar system behind Ceres. But basically, these meteorites we think came from there, and the Howardite-its in particular sample mixes between 2 other kinds of meteorites, eucrites and diogenites. So when you take them up and you break up the whole body and you bring material back of stuff that's been heavily mixed, almost like stuff from the moon, except this is from Vesta, you get stuff that looks like this with this sort of texture. So when I did the classification, whenever I do HEDs and lunars, I always sort of do the approach where I look at where the different clasts are and I try to go to those. And I try to see what what I'm really sampling here. And one thing about this meteorite that was very interesting was that I was getting some chemical compositions of some of the clasts that were very different from what I would expect from a diogenite or a eucrite, because diogenite and eucrite material have very specific signatures you see for some of the minerals, and I can say, all right, this is a diogenite class, this is a eucrite class, but I was getting something that was a little different. So what I was sampling were these things called magnesium-rich Hertzbergites or magnesium-rich olivines or pyroxene clasts. And I went into sort of reading some of the literature on these because I haven't seen these before. And it turns out that they have been found in a few other anomalous HEDs. And these, some people think come from the lower crust of 4 Vesta. Some people think these might come from the mantle of 4 Vesta. There's sort of a little bit of debate going on from there. But there's very few samples that these have been reported in. And I think a lot of the work that's been done was actually Antarctic HED meteorites that they found these weird magnesium-rich clasts. So I found a few of them in this meteorite, and I said, this can't be a typical Howardite. It's got some anomalous material in there. And the last thing I have to say is the one of two, I don't mean to sort of mean it in sort of a different perspective, but it's not as rare as it should be. I think there should be more of these Howardites that have this anomalous material. I just think they haven't been really extensively studied in the detail that you would be able to find these weird, unusual mineral grains in there. I think there's more of this, and there are quite a bit of anomalous diogenites that exist that have this same exact material in them. But of course, the difference between why it's a Howardite and why it's a diogenite is because Howardites, by default, have to have at least 10% eucrite and diogenite component in them, whereas diogenites just need to be 90+% diogenite. But I do think there is more material that has this, but it is anomalous compared to most of the Howardites that we see. Hence why I called it Howardite anomalous.
But now that you've classified it and called that out in the write-up, hopefully other scientists who will be doing their classifications in the future will look for that, or if they find it, they'll be more apt to identify it, call it out, and get that anomalous as well until we get a grouplet.
Absolutely, yeah. Until we can at least have a further subdivision in the Howardites or some kind of further distinction that we're sampling other types of clasts that they probably are there in other Howardites, but this meteorite, this image is a pretty big sample. And whenever you're choosing spots to do the mineral chemistry, you can't do the whole thing. It's kind of impossible. So you have to decide on some areas. So I just happened to hit a few weird areas, but I'm sure these exist in other Howardites.
Fantastic, man. Again, thank you, sir.
No problem.
Okay, so next we're going to move on to the lunar and Martian classifications.
Yay, finally. I love me some lunar.
So the only really rare one is the lunar milk breccia. That's one of 28, I think that classification has grown quite a bit over the last year or two. But for our featured lunar or Martian, we're going to show you a Martian Shergottite, NWA 16337, which Matthew Stream is the main mass holder for. He is out hunting or camping, or I think camping right now. So we are going to show his meteorite for him. We have a lot of pictures that he has taken and a little video. But this is found in Algeria in 2023. It was classified by Anthony Irving and I'm not sure what the first name is, Pete Carpenter. Two different institutes classified that.
Good looking good looking Martian. Look at that.
Nice crust on the outside, really nice matrix on the inside.
Yeah, I mean, I'd have to look at the classification, but it doesn't look very weathered at all. Wow. I think he has a brief video here.
Yeah, just a brief one. Nice polish on it too.
Yeah, if you don't have a hand hunk of Mars, I highly recommend go get one. Well,
Eight. So next we're going to look at chondrites. All right. So the first chondrites we always look at are carbonaceous chondrites. The most rare one we have here is a CO3 anomalous, and that one is one of four. So the first one we're going to look at is one from our buddy Yang, and that is 14287. He has a video. So this one was in classification for a few years. He was hoping for a CO3 anomalous classification. The official classification just is CO3. It is a little bit harder to get the CO3 anomalous, but they did put CO3 anomalous in the write-up in the MetBull. It is magnetite bearing, and it has typical texture features of a CO3 chondrite, but the camosite and taenite are notably rare, and it has low, I think it's chromium magnetite, is the main accessory phase, along with the pendulandite. I don't know how to say that word. I'm so sorry. So yes, thank you, Yang. All right, our next feature, we have a few carbonaceous chondrites to take a look at. So the next one is NWA 16518, and this is a CV3 from Jason Whitcomb. We have a few pictures of this one.
you call these space raisins?
No, that was a different one.
Oh.
Very
Yeah. I'm glad that they're giving a little bit more breakdown into these, because it seems like CV3 is a stamp they put on a lot of meteorites.
Well, this one is a CV3. Yeah. It was classified by Chris Hurd, but the very next one we're going to take a look at when you go to the next slide is another one that Chris Hurd actually classified for him, and this one is a CV Red 3. So this one has a little bit deeper into the subset. This one was found in Northwest Africa in 2022. And Jason is the main map holder for this one too. And this one again is a NWA 16512.
That's beautiful.
Yeah, pretty nice.
In this previous picture, you can see CAI just hanging out. Yeah, well, yeah, I don't think that's a chip. I think that's an actual CAI. That's beautiful.
Well, I said we had a lot of carbonaceous, but now I'm thinking it's a lot of LLs we're going to look at later. But let's move into ordinary chondrites. The first slide, we have just our miscellaneous that I don't really, Rudies and Enstatites. And so this EL melt rock, this one is EL melt rock. I know we all are familiar with them, like Alhagunia and stuff like that. It's actually not a major, I think there's only like 27 of them. So, yeah, so it's somewhat pretty rare still. All right, moving into H's. So we don't really have anything really rare, but I do have an H to share, and that is one of Yang's again, and he has a video for us on here. All right, so this one is an H4 melt breccia. It was found in Northwest Africa in 2022. It was actually, we were just talking about enstatites. It was actually sold to Yang as an enstatite, but the seller ended up being totally wrong. It's a heavily weathered OC. It has a weathering grade of like 3 to 4. And yeah, so it's an H4 melt breccia.
Wow. I wish we had a look at a better, another slice of it. I want to really see that. I have to hit up Yang after this. I'm interested in that. Oh, okay. Sorry, babe. Back to you.
All right. So our next set of classifications are the L's. We do have some rare ones. There are the L3.10 and L3.15. But for the one that we're going to feature is from one of our crew members. It is NWA 16529, and that is main mass holder is Chris Monk of Rocks on the Ground. He usually does live show and tell with us, but He's been working a lot lately, so we're going to show it off for him. And this was actually classified by Daniel as well. So we have 2 pictures that Chris shared with us. Really, really pretty meteorite.
I think Chris was actually going for, because I know he got an L3, but I think he was going for one of these spots right here, the 3.1, 3.15. That's where he was going for. Sometimes the rock doesn't
Long
land
time.
there. Yeah. Yeah, but absolutely beautiful, beautiful rock.
Yeah.
Well, congrats anyway on an L3, buddy.
All right, so next we're going to the LLs. The only really rare one there is the LL3-7. Well, and the LL3.15 is probably pretty rare too. So we have a few of these. So for the first 2, these are from Jason Whitcomb. And so they are both found in Northwest Africa in 2022. They're both LL3s. And so as we look at the pictures of this first one, NWA 16517, try to take a look at it. It's going to be what he wanted to show us, the differences. This one has a shock level of 1, whereas the next one we look at has a shock level of 4. But compositionally, they are very similar except for that shock level. So we'll see if you guys can tell the difference.
So this is the shock level 1 close up.
Yeah, Yep, exactly. Look at that. Sexy.
And so everyone take a mental note of that, because it's nice to look at the same type of material with different classification of shocking or weathering, because you get to see how those affect the interior matrix as well.
Yeah, for sure. So the next one is NWA 16521. And like I said, it has all the same information, but this one is shock level 4. And then also you will see that there's multiple stones, and Jason has cut into all of them. And what he tries to do when he gets things classified, and we all know that he knows what he's doing because he probably has a few hundred classifications by now, he tries to give examples from all of the stones. And he does this to help minimize like sampling bias and just make sure that his lots aren't stuffed in with a bunch of other like field pairings. But we can see the shock level 4 in this picture. So I can see the difference for sure. What are you doing, Topher?
I want to do a side-by-side.
I should have probably put that in there. Yeah, I can totally see a difference.
Yeah. Absolutely. The background doesn't seem to be the matrix in between the chondrules is not as dark, and a lot of the small ones are not as fine lined anymore.
Yeah. Yeah, so I thought that was kind of cool that he gave us examples of that. All right, so another LL. Jason was really busy with. He said it was LL3 day at the nomenclature committee. He got all of his LL3s kind of sent through at the same time. So this one is NWA 16522. He did tell me that some of the unpolished faces need finishing. His saw blade was he cuts a lot. His saw blade was getting a little dull and a little overheated. And so you can see some of the darkening in the shape of the cut, but he will be finishing those up and making them look really pretty. And you know, Topher, from experience, you just got a new blade for your saw. And
yeah.
I hear you, you were just going crazy over it, like,
oh my God.
Much better. Okay, so for our next LL, which is another one from Jason. This one is one that he worked on with Daniel, and he is really excited about cutting into this one. There's a really big, he's cut into smaller stones, but there's really big ones that he hasn't cut into yet. This one is NWA 16551, found in Northwest Africa, 2022. Ooh.
Yeah, Jason's a busy man.
He is. So yeah, that's the big one. He said he's excited yet about cutting into it.
Oh, look at this loaf of bread. Wow. Jeez, that chondrule is crazy.
Yeah.
Wow. Yeah, that's definitely what you want to see on the outside of
Yes,
these.
kind of popping out. Are you
Mm.
enjoying that, Pat?
Wow.
Oh yeah, I'm salivating.
All right, so our next one is from our buddy Yang. This is his LL3. We'll take a look at his video on the next slide. So this is NWA 16634. The write-up, he did get an LL3 classification, but the write-up in the notes said they say it's an LL3.15. Look at that. But he says the committee takes a lot more conservative approach when it comes to subtyping. So if you want to get a quicker approval, it's easier to go with LL3 and then just get the subtype referenced in the write-up. So that's what he did. All right, our last classification section. We're getting close to the finish line. All right, so irons and stony irons, and it looks like I forgot to share how many there were. Oops, there weren't many. There were a few irons, one palisite, and a few mesositerites. So our featured iron is one that I think a lot of you are familiar with, and that is NEA051. And so Scott McGregor was going to be with us live tonight, but he had a change of plans, family flying in, and many of you may not agree, but I always say family first over meteorites. Sorry. All right, so this picture was provided by the classifier, Christopher Hurd. And then on the next one, we have the picture provided, and a lot of you may have seen this on Facebook or maybe on Meteorite Picture of the Day. This was provided by Craig Zlimen. And so there was a write-up that Scott did on the Meteorite Picture of the Day, and this is the story he was going to tell us live, but I'm going to try my best to retell it for him. So he said, like the story of the cute puppy at the animal shelter who wants to come home with you, Craig Zlimen posted that first picture we saw of the Facebook cluster saying to cut or not to cut. This is a really beautiful iron. So I guess 11 kilograms for sale or it gets the saw. So the next few, yep, here we go. Scott McGregor decided to take this puppy home, and he acquired a brand new doorstop, which you'll see in these three pictures. So then on the next set of pictures, the next two, he said, besides the overall aesthetics, what was most interesting about this one is the large, squarish crystalline inclusion. And he says it's very hard, so it Troilite was rolled out, and while it's glassy and metallic, it didn't have the needle shape typical of Schreibersite. So maybe he said he was fantasizing. We thought maybe it's a large diamond inclusion. Turned out it wasn't. Craig had two pieces, and so he was able to acquire the main mass and then this slice from the smaller 8-kilogram piece. And so Dr. Calvin Alexander at the University of Minnesota kindly offered to do an XRF scan on the inclusion surface, and it came back as high chromium. So chromite is a common inclusion of many iron meteorite classifications, but it's usually present in smaller grains. So to confirm the inclusion composition with some difficulty, he managed to chip off some of the smaller pieces. And these were sent to Dr. Jennifer Mitchell, who's also at the University of Minnesota, who offered to do an SEM analysis on it. And now the result is confirmed. It is a huge chromite crystal. So research chromite crystal or inclusions didn't turn up much, except for one very relevant paper by Carl Thomas Fair and Elaine Carrion, describing pseudo-hexagonal chromite crystals up to 3 centimeters in St. Aubin, also a type 3AB. So hard to be sure of the exact dimension of the crystal or crystals without cutting, but the chromite crystal in this NEA 051 seems to be even larger than the ones described in St. Aubin. So besides that one, it also has, and you can see on the slices, if you go back to the slices, they have long Schreibersite needles, which you can also see here. So, and St. Aubin has those as well. So lastly, and I'm not sure if he's ready or not, but we're going to go to Topher, who's going to do some live show and tell of his slice of NEA 051 that he acquired when he was in Tucson hanging out with Craig.
Yeah, I'm gonna show that one off, but we have 3 pictures here from.
Oh yes, I forgot Sorry, right before we go to show and tell, Jules actually is a specimen holder of NEA 051, and she took some amazing pictures too. So I wanted to share those. I saw those on Facebook, and I'm like, Jules, why didn't you tell me? I didn't realize, and of course I put it together. I'm like, that's right. Is this the same iron that's in our calendar too?
Yes.
Okay, cool. Yeah. So I like how that all came full circle. Congratulations on your name in the MetBull again, Jules.
Oh, see, it won't let me zoom, but this is like a drop dead gorgeous piece. This is the ugly side, but this is like the iron of my iron collection. Look at it. It looks like Japanese writing on there, doesn't it? This is gorgeous. And I really wish I could zoom in, but you see around the inclusions.
I'm reading comments, Topher, and Ken put, damn!
Yeah, that's actually what it says in Japanese right there. That's damn.
Damn in Japanese.
Yeah, it's like, damn, nice. Yeah, but this, I really wish I could zoom in on it because there's so much detail in this one. But yeah, this is an absolute gorgeous meteorite.
Congratulations on your name in the MetBull again, Jules. Thank you, everybody, for watching. If you want to go back and search our YouTube videos to watch past MetBull updates, just do that. There's a good collection of them now. Yeah. So hopefully we'll be back in about 2 more months. So we'll try to catch up in July on the May and June classification. So thank you so much for watching.
Yep. Thanks a lot, guys. I wanted to do a quick shout out for myself, for our Patreon. If you guys love this type of education, this doesn't happen by itself. This takes Sue hours and hours and hours and hours of putting it together and working with people. If this is something that you enjoy, we would love to show you. We would love to see some appreciation on Patreon if that works for you. It's $10 or $25 a month, and you either get the money back or you get something else for it. It's a win-win for everyone, including science. So thanks a lot, guys, and we'll see you next week. Everyone wave the camera like an idiot. See ya. Good night, guys.